We have to buy the equipment, we have to install it and operate it and create the jobs all as per the plan in order to even have any of this incentive come back to Tesla. So yeah, it's 100% performance based.
And it's over 20 years. And we only earn it over 20 years. In order for Tesla to earn that money over 20 years, the Gigafactory has to generate over $100 billion in revenue. So again, it's basically a 1% discount. It's helpful to have that, and it's not, it's appreciative to have that, but it's not. It's and obviously, if someone in the press were to write, Tesla receives 1% discount on Gigafactory, that would get no clicks, because it's lame. But that's actually the situation. And like I said, that Nevada doesn't. Like, if we don't have that equipment, Nevada doesn't still pay us money. So it's a no-lose proposition for Nevada. And that's why I wrote a blog, titled "The House Always Wins." Okay. Nevada is very familiar with the House. So I think it's real important to clear that up. And I particularly wanted to spend time on this because obviously we're in an election year. And so what happens in an election year is, like, particularly Tesla gets sort of made into a political football and kicked around quite a bit. Yeah, I mean, in the last one, there were 3 presidential debates. Of the 3 presidential debates, Mitt Romney attacked us in 2 out of 3 by name. Like, that's a lot of time to spend on a little company. And I don't think he came up with that attack by himself. That was not. Somebody made him do. Somebody asked him to do that, and somebody with not good motivations. So he actually called us like a loser. It's like, okay, well. And he said, like, Tesla's. Tesla is like a loser of a company or something, and I mean, he got the object right, but not the subject. And then, in terms of the Tesla fleet, a lot of people question: is Tesla going to be able to make 500,000 cars a year? That's such a big jump from where we are right now. We're hoping to sort of be at an annualized rate of somewhere between 80 to 100,000 cars a year by the end of this year. And so how do we go from there to 500,000 cars a year? And that's where I think it's important to just point out, like, we've made much bigger leaps than this in the past, going from 500 or 600 Roadsters a year to where we made half the car, to the Model S, to where we made 20,000 cars, and we made the whole car, and it was a much more complicated car. And you can see, essentially, going from the sort of in terms of fleet, going from 110,000, going from let's say 5 years ago where we had, or 2010 where we had roughly 1,500 cars total, to 5 years later with 110,000 cars. That's a pretty big leap. So I think it's certainly going to be a challenge with the Model 3. It's going to be hard, but it's. I think we've shown that the Tesla team is really dedicated, and that it's something we can make happen. And then particularly with thinking about the mistakes we've made in the past, where we've sort of overcomplicated products like the Model X, and if we're really making sure that we don't do that with the Model 3, and that we have a tight interaction loop between manufacturing and engineering and design, so that we design a car that is easy to make, and that, if there are cool features, it's great. We'll table those to version 2, version 3, version 4. And maybe it's worth making another point, because sometimes people ask me, like, when should I buy like a Model S or a Model X? And it's like, are you going to make an improved version? I'm like, of course. So I mean, if we're always going to keep improving the product, and so if somebody wants to wait until Model S or X stops improving, well, they're going to be waiting forever, because we're going to keep improving the product every year, sometimes every 6 to 9 months. So I think generally, the right time to buy a car is always now. And then depending upon how much you like new technology, then buy a new car at whatever that periodicity is that you think makes sense. So just talking about the future. I think that the most important point I want to make is that, what I referred to earlier, that we've realized that the true problem, the true difficulty, and where the greatest potential is building the machine that makes the machine. In other words, building the factory. And really thinking of the factory like a product. Not sort of a hodgepodge of things that are bought, where the machines are kind of bought from a catalog. But actually, just like we do with the car, we don't try to create a car by ordering a bunch of things off a catalog. We design the car the way it should be, and then we make, either we or with working with suppliers, make all of those individual components. And there's almost nothing in a Model S that's in any other car. And I think the same approach is the right approach to take when building the machine maker, the factory. I actually think that the potential for improvement in the machine that makes the machine is a factor of 10 greater than the potential on the car side. I think maybe more than a factor of 10. And I've really come to appreciate that, over the last 2-3 months in particular, when I've sort of just been on the production floor all the time and sort of seeing things, running production personally at a detailed level. I don't even have a desk or an office anymore. I'm just basically standing on the production floor and occasionally meeting in a conference room. And it's like, wow. I do my favorite thing, which is apply physics first principles. It's like the best tool possible. And it's like, wow, when you think of a production facility on a fundamental level, for a given size of factory, the output is going to be volume times density times velocity. So then let's sort of look at our factory and say, okay, what is the density of useful to non-useful volume? It's crazy low. It's like 2 or 3%. If you look at volumetrically, not just on a planar level, but volumetrically, it's literally 2 or 3%. When you say car to non-car ratio, volumetric ratio, like, wow, okay, that seems like there's a lot of room for improvement. And then you say, like, velocity. What is a reasonable expectation for the exit velocity of vehicles from the factory? And at first you may think that, say, some of these advanced car factories around the world are very good at making cars, and they may make a car every 25 seconds. And that sounds fast, but actually, if you say, well, the length of the car plus some buffer space is approximately 5 meters, and so it's taking 25 seconds to move 5 meters. Okay, that's 0.2 meters per second. Basically, you're not much faster than a tortoise at that point. And so it's like, wow, that really doesn't seem fast. Like how come these factories, like a sort of slow walk would be approximately, or slow to medium walk would be 1 meter per second. And a fast walk would be 1.5 meters per second. And the best car factories in the world are doing 0.2. Like, seems like you should be able to have cars exit at least walking speed. This doesn't seem so crazy. And then the density improvement, like there may be as much as an order of magnitude improvement in density possible as well, going from maybe 2 or 3% to 20 or 30% of the volumetric density being optimal. And like you can also think of it like the design of a modern system on a chip or a computer. And you say, if you look at, say, the complexity of the board, and you see how close together the line traces are, and how focused things are on clock speed and data transfer from RAM to, say, a solid-state disk or the internal CPU cache. It's like, wow, there's crazy potential for improvement here. I think at least an order of magnitude potential for improvement on production. And so with less, like significantly less engineering effort, we can make dramatic improvements to the machine that makes the machine. I think I think like probably a lot of people will not believe us about this, but I'm absolutely confident that this can be accomplished.
Yeah, there are opportunities we're finding all over the place, and as you start to shift some of the design resources that have been improving motor technology and power electronics or batteries, and are working so hard to try and find 0.1% of efficiency gain or performance gain on those different systems. And when they start to go and look at the factory, they say, "Oh my gosh, this is crazy." We can find, as you were saying, easily tens of percent or 20, in some cases hundreds of percent efficiency gain that were sort of unheard of in terms of what you could do in the design world. So the impact there is pretty phenomenal and quite close at hand.
Yeah, so we're basically going to design a factory like you design an advanced computer, and in fact, I think use engineers that are used to doing that and have them work on this. And I found that like once you sort of explain this to a first-rate engineer, the light bulb goes on. They're like, wow. As JV was saying, like they spend huge amounts of effort trying to get a fraction of a percent of improvement on the product itself, but actually that same amount of effort will yield an order of magnitude greater result if you focus on building the machine that builds the machine. And it's just that a lot of engineers don't realize that this is possible. They think that there's like a wall. They're basically operating according to these invisible walls. So we just need to, we're in the process of just going through and explaining those walls don't exist. And I think it's going to be pretty amazing. So just thank you to everyone who's a shareholder and to our customers and the Tesla team. And my apologies for the long story. I hope you enjoyed it. And now we'll go to Q&A. Yeah. Sorry? Oh, wait. Sorry. Yeah. So.
All right, everybody. I can give you the instructions for the Q&A if you have the endurance to stick around.
And just before that, we wanted to bring in some of the longest standing Tesla employees. Hey guys, can you come up on stage? So. So these are just people that have been with the company for on the order of a decade, and just. We're gonna need 2 lines here. All right, guys, just want to say, thanks for all the many late nights and weekends and intense effort along the way, and it's been an honor working with you. Yeah. Thank you.